small unit conversion at the end. Isn't that important? Okay. So here we've got a particle of charge Q. Q equals minus 8.7 microcoulombs, sorry. Has a velocity of 625 meters per second, and it lies in the XY plane. And makes an angle of 65 degrees. So there's my V vector. And so that there's V cosine of 65 and V sine of 65. So my velocity vector can be written as 625 meters per second cosine of 65. That's going to be xy. I hat plus 625 sine of 65 j hat, which comes out to be 264.136 meters per second I hat plus 566.442 meters per second j hat. Okay, so there's my velocity vector. I haven't finished reading the question here, but I figure we're going to need its components. So it makes an angle of 65 degrees with respect to the x-axis. So there's our velocity vector. We've got a constant magnetic field in the y direction. So there's our B, and it equals 1.6 Tesla. What are the magnitude of the magnetic force on the particle? So it's looking for magnitude, but we can get direction as well. So F is QV cross B. So the way that I usually remember to do this here is with determinants. So this is minus 8.7 times 10 to the minus 6 coulomb. And the way you do this with determinants is by having our x, y, z, and then you place the velocity in here. So 264.136 meters per second, 566.442, and 0. Our B field is 1.6 Tesla. And so we take the determinant of this matrix, and so the determinant comes out to be, well, I'll use I hat, J hat, K hat in retrospect, just to be consistent. All right, so in the I hat direction, we have 566.442 times 0. So it's this, minus 0 times 1.6. So that's just going to equal 0, obviously. Minus j hat times this. So that, again, is just going to be 0. I'm not going to bother writing these all out, in fact. So this is just going to be times 0. That's times 0. And then plus k hat times, so in the k hat direction, we've got this minus this. So we can see that the minus is going to be 0, but we've got 264.136 times 1.6 Tesla. And so then that equals, so then the I hat goes to 0, the J hat goes to 0, and all that's left is the K hat. And then we just multiply these things up, and we get minus 3.6768 times 10 to the minus 3 newtons in our k hat direction. If we're just looking for magnitude, so the magnitude of our force is just 3.6768 times 10 to the minus 3 newtons. So obviously we could have, right from the get-go, said that our force is just going to be, because the B field was in the J hat direction or in the Y direction, we could have just multiplied our X velocity by our B field in the J to get our force in the K. So there's or alternatively, as they've done, we could have expanded the cross product as a sine theta and determined the angle between the two. And so that could have been done as well, which is what this person did. And so this is still correct.